Today marks a historic milestone for the AI community. This day may go down in history as the moment AGI, Artificial General Intelligence, became a reality. If you're wondering why, it's because OpenAI has officially announced their new O3 model, the second iteration in their O1 series. This model is designed to excel at extended reasoning and critical thinking. What makes this moment so significant is that the new system has outperformed humans on the ARC benchmark. For those unfamiliar, the ARC benchmark is highly regarded because it's specifically designed to resist memorization, making it a true test of general intelligence.
So ARC is intended as a kind of IQ test for machine intelligence. And what makes it different from most LLM benchmarks out there is that it's designed to be resistant to memorization. So if you look at the way LLMs work, they're basically this big interpolative memory. And the way you scale up their capabilities is by trying to cram as much knowledge and patterns as possible into them. And by contrast, ARC does not require a lot of knowledge at all. It's designed to only require what's known as core knowledge, which is basic knowledge about things like elementary physics, objectness, counting, that sort of thing. The sort of knowledge that any 4-year-old or 5-year-old possesses, right? But what's interesting is that each puzzle in ARC is novel, is something that you've probably not encountered before.
Now, if you're curious about what ARC looks like in this test, one that humans can easily pass but AI systems currently struggle with, take a look at the examples shown right here in this video.
Example here. AGI is all about having input examples and output examples.
Well, they're good.
They're good? Okay. Input examples and output examples. Now, the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. What's interesting, though, is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC AGI Pub. So congratulations.
For those of you outside the AI community, this might not seem like a big deal, but it truly is. This achievement represents something we've been striving to solve for about 5 years. It's a benchmark widely regarded as the gold standard for AI development. Reaching this milestone marks the first time we've created a system capable of outperforming humans in a task where AI systems have historically struggled. What makes this even more fascinating is that they developed 2 versions. We worked with 2 configurations of the O3 model, one with low tuning and the other with high tuning. The low-tuned O3 model is designed for minimal reasoning effort. It operates with reduced computational demands, making it optimized for speed and cost efficiency. This version is ideal for simpler tasks, such as basic coding and straightforward problem-solving, where deep reasoning isn't necessary. On the other hand, the high-tuned O3 model is configured to handle more complex challenges. It invests additional time and computational resources to analyze and solve problems, excelling in tasks that require deeper reasoning and multi-step problem-solving. What's fascinating is that by fine-tuning the model to engage in longer, more thoughtful reasoning, it not only improves performance but can also surpass the capabilities of human reasoning in specific areas. What's remarkable about this is that the creators of the ARC AGI benchmark have stated that its performance demonstrates a significant breakthrough in novelty and adaptation. This isn't just incremental progress. We're stepping into uncharted territory. Naturally, this raises the question, is this AGI? However, AGI O3 still struggles with some simple tasks, which highlights key differences from human intelligence. The person you saw at the beginning, Francis Cholet, shared his thoughts on the topic. He mentioned that while this might not qualify as AGI, artificial general intelligence, just yet, it represents a significant milestone on the path to WSAGI. Cholet pointed out that there are still numerous challenges AGI models face. For instance, ARC-AGI-1 struggles with many tasks, and early indications suggest that ARC-AI2 will also remain highly challenging. He explained that this progress demonstrates the feasibility of creating benchmarks that are engaging and straightforward for humans, but exceedingly difficult for AI to tackle without specialized knowledge. According to Cholet, achieving AGI might require creating evaluation metrics that AI simply cannot overcome, something he suggests is not yet possible. Some critics might argue that this shifts the goalposts, implying we'll only recognize AGI once surpassing such benchmarks becomes entirely unattainable. However, this perspective contrasts somewhat with what Cholet said earlier this year. For instance, 6 months ago, he commented on the benchmark surpassing 80%, which, as of today, has been achieved.
Around to you. So suppose that it's the case that in a year, a multimodal model can solve ARC, let's say get 80%,
Sure.
whatever the average human would get, then AGI?
Quite possibly, yes. I think if you start, so honestly, what I would like to see is an LLM type model solving ARC at like 80%, but after having only been trained on core knowledge related stuff.
One of the earlier predictions about the model highlighted its limitations, particularly regarding compute costs. As you can see here, the question is raised. Does this mean the ARC prize competition is defeated? The response is no. The ARC prize competition focuses on a fully private dataset, making it a different and somewhat more challenging evaluation. However, what's notable about the ARC prize is that solutions must operate within a fixed compute budget, around 10 cents per task. This makes the competition especially intriguing. I'm not sure if you've noticed this, but if we take a closer look here, specifically at the bottom, you'll see that O3 has fine-tuned the compute resources allocated to this model. This means the model's operation costs around $11,000 per task, which is quite steep if you're planning to use it for any practical application. These models, designed to search across numerous solutions, inherently come with high costs. For instance, this particular example shows costs exceeding $1,000 per task, which is undeniably expensive when you consider using it for routine operations. However, as we've seen with most technologies, costs tend to decrease over time. Early innovations were often bulky and expensive. Think of large, old-school TVs or massive, brick-like mobile phones. But as technology evolved, it became more efficient, faster, and cheaper. It's likely we'll witness a similar trend with AI. The fact that they've hit this performance benchmark now is significant. It sets the stage for further improvements and cost reductions in the future. What I find fascinating about this is that just 2 years ago, he stated that the ARC-AGI benchmark being fully solved wouldn't happen for at least 8 years. Now he's saying there's a 70% chance it could happen in less than 8 years, maybe even in 4 or 5. It's incredible to see how AI continues to exceed most people's expectations. We also noted that it performed exceptionally well on the SWE benchmark, which is known to be a challenging test for software engineering. For software engineers, this might not be the most reassuring news. However, with more people now engaging in coding, there's likely a growing demand for software engineers who truly understand the code being generated. What's particularly intriguing here is that during the course of making this video, I realized something surprising. This is actually O2, not O3. I just want to quickly go off on a tangent here because, as I was reading about the breakthrough with version 03, I realized something important. This is actually only the second iteration of the model. Some people might assume that 03 means it's the third iteration, but that's not the case. Version 02 was skipped because there's a conflict with O2, which is a British mobile service provider. So what we're seeing with 03 is actually the second iteration. This highlights the possibility that future versions, like 0.3 or even 0.4, could bring significant advancements and potentially reach benchmark saturation. Let's also take a look at the math and PhD-level science benchmarks. We can observe a notable improvement in these areas as well. However, I do believe we are reaching the point of benchmark saturation. For example, in competitive math, the score is around 96.7%, and in the science category, it's 87.7%. As I mentioned earlier, many people are starting to say that AI progress has slowed because it's no longer increasing at the same rapid rate as before. What we need to understand is that as these benchmarks approach scores of 95% or higher, the incremental improvements become more difficult to achieve. First, there's only about 10% remaining to reach perfection, and secondly, it's highly likely that 3 to 5% of the questions are flawed, meaning errors exist within them. As a result, achieving 100% on certain benchmarks is simply not feasible. That's why they decided to create the Frontier Math Benchmark. When the benchmark was first released, which was about 2 or 3 months ago, the models that were capable of answering only 2% of these questions were Gemini 1.5 Pro, Claude 3, Sonic, and you can also see 0.1 Preview and 0.1 Mini listed among them. It's important to note that Noah Brown, who works on reasoning at OpenAI, mentioned that the development of AI will continue on its current trajectory. So, for those of you wondering if AI progress is slowing down, it's clear that this is not the case. Additionally, we had the chance to hear from Sam Altman in an interview where he shared his thoughts on what he believes AGI, Artificial General Intelligence, is. As I've mentioned before, the definition of AGI is constantly evolving and changing. Thanks for watching. Don't forget to like, subscribe, and hit the notification bell so you never miss an update. See you in the next part.